Hello students, welcome back. So today I'm going to be talking about Python's built-in modules. So one of the most common built-in module is a math module. So what exactly is a module, by the way? It's a file. It contains your functions, variables. So this way you don't have to define your function. This way you don't have to define your variables. This way you can use those functions and variables. Now Python actually has a lot of built-in modules, and one of the most common one is a math module. That's the one we'll be studying. So what math module does, as the name indicates, it helps you perform mathematical operations. Now, before you use any one of the functions from your math module, you have to import your module. So let's import our module. So this is the way I'm importing it. Run this cell, and now your module is imported. I want to see what's inside my module. So there's a method called dir, and just specify the name of the module, and that's going to print out all the functions, all the built-in methods that's available inside your module. And these are the ones. So we're going to go over some of them, the ones that are important ones. Depending on your line of work, you have to find the ones that you actually use or that you may need in your line of work. Now, let us look at some of the common math functions: square root, power, absolute value. So let's start with the square root first. So suppose I want to calculate square root of a, which is a in this case is 25. So the way you do, you call this inbuilt method sqrt, which is short for square root. So math.square root and pass in your argument a. In this case, this is my a, and then you print out your result. So when you run this, it's going to print out 5. Square root of 25 is 5. What about power? So let's say you want to calculate 2 to the power 3, something like this: 2 to the power 3. So in order to calculate that, you invoke this method math.pow, which is short for power 2 comma 3, and you print your result, and your answer would be 8. How about absolute value? A lot of times you actually come across numbers where you want a number that is positive. In other words, you only want the magnitude of the number, only the absolute value of the number. So in this case, my a equal to minus 10. You call math.fabs, which is short for absolute value, and you pass in your a. When you run this, it's going to print out the absolute value of a. Now let's look at rounding numbers. So there are two main operations: floor, which is round down, and ceiling, which is round up. So let's look at the floor one first. Suppose my a equal to 4.9. So in this case, you call math.floor a, and what it's going to do is going to round down. So when you run this, it's going to print 4, because when you round down 4.9, it rounds to 4. What if you do 2.9 or 3.9? When you run this, it's going to print 3. So it's always going to print the rounded version or round down version of your decimal number. What about ceiling? Well, this is opposite of that. This will round up. So in this case, if you run this program, if you say math ceil 4.1, it's going to print out the 5, because when you round up 4.1, it becomes 5. Now, in this math module, your trigonometric functions, they work in radians, not degrees. So let's look at a function that converts degrees to radian first. So suppose your angle degree is 60 degree. The way you convert into radians is that you call radians inbuilt method. You pass in your angle degree, and it's going to print out your angle radian. In this case, it's 1.04. So when it's 60 degree, turn into radian is this right here. Suppose now you have to calculate sine, cosine, and tangent of each one of these angles. Suppose your angle is 60 degree. The first thing you do, convert into radians. That's what this line does, and then you print out the sine of 60 degree, cosine of 60 degree, and tangent of 60 degree. And when I run this, it's going to print out its corresponding values over here. Now your math module also has some constants defined in it that you can use. For example, pi, Euler number. So if you want to access pi, you can just say math.pi. That's going to give you the value of pi. In this case, this is the value of pi that is defined in your math module. What about Euler number? In this case, your math.e would be Euler number. When you run this, this is your Euler number. So this way you can use your pi and Euler number and don't have to define your pi and Euler number. And what about the logarithmic functions? Well, you can have either logarithmic function base e, or you can have logarithmic function to the base 10. So suppose you want to calculate logarithmic function to the base e. Well, when you run this, it's going to give you 1, because log of math e, which is which your Euler number, is 1. And by default, log over here, this would be base e. What about log to the base 10? If you want to calculate log to the base 10 of 100, and the answer would be 2 over here. And then there is factorial. Suppose you want to calculate factorial of 5, 5 factorial. So if you remember from a high school math, it is 5 times 4 times 3 times 2 times 1. So in this case, you can actually calculate this value by calling this function right here. So in this case, I'm calling math.factorial function and pass in your 5. When you run this, it's going to print factorial. And then there is area of a circle. Suppose you have a circle given to you like this, and you want to calculate this area, and the radius is 7. The radius is 7. So in this case, if you remember from your high school math, your area is equal to pi r square. So in this case, I'm just calling math.py, that will be your pi, and then r square would be done using this function right here, POW radius comma 2. And then when you calculate, when you print your area, when you calculate your area, the answer comes out to be this right here. Suppose you have to calculate hypotenuse of a right angle triangle. Suppose this is one of your side, this is a equal to 3, and this side your b equal to 4, and this is your right angle triangle, and you have to calculate this right here. But if you remember from your high school math, your hypotenuse is given by a square plus b square. You can actually use that, you can actually calculate this using your math.sqrt function. So in this case, this will be my a square plus b square, and then I'm taking square root of that. And when I print my hypotenuse, the answer comes out to be 5.